Music is all around us. From the birds singing in the trees to the radio playing on the beach, sound waves are everywhere. And music is just one part of those sound waves. But what exactly are sound waves? How do they work? And what makes them different from other types of waves like water waves or light waves? Well, it's all about vibrations. Everything around us is made up of tiny particles that are constantly vibrating. When a speaker vibrates, it disturbs the air molecules immediately outside it. And those air molecules collide with ones next to them. And they collide with ones next to them and so on, like dominoes passing on the vibration. These vibrations travel through the air like a wave. Just like when you drop a pebble into a pond and the water ripples outward, this wave of vibrations is what we call a sound wave. Unlike water waves, which have peaks and troughs, sound waves have areas of high pressure called compressions and areas of low pressure called rip. When you make a sound, like by strumming a guitar string, the string vibrates and disturbs the air molecules immediately beside it. Those air molecules collide with ones next to them, and they collide with ones next to them, and so on, creating a compression that travels down the string like a Mexican wave at a baseball game. The end of the string is attached to the guitar, so when the wave of compressions reaches it, it gets bounced back the other way. Where the two waves of compressions meet, the particles of air collide with each other, creating an area of even higher pressure. This high-pressure area is the sound wave's first node, or a place where the wave has the highest amplitude or height, like the top of a mountain wave. As the wave continues to travel, more nodes and antinodes or low points form, and the wave eventually dies out, or dissipates, as its energy is used up by friction with the air molecules. Now, just like with water waves, the size of the sound waves, peaks and troughs, or compressions and rarefactions, is called its amplitude, which determines how loud or quiet a sound is. A bigger amplitude means a louder sound, while a smaller amplitude means a quieter sound. The space between each wave is called its wavelength, which along with the wave's frequency determines the pitch of a sound. Pitch is how high or low a sound is. The number of waves at a second is the wave's frequency. So higher frequency means higher pitch, and lower frequency means lower pitch. And just like with water waves, the properties of sound waves allow us to do some really cool stuff, like create standing waves. When two waves of equal frequency interfere with each other, they form a new wave with a larger amplitude. This is called constructive interference. When the peaks of two waves line up with each other, the result is a wave with an even larger peak. Similarly, when the trough of one wave lines up with the trough of another wave, the result is a wave with an even larger trough. But sometimes, the peaks of one wave line up with the troughs of another wave. When this happens, the waves cancel each other out, and we get a resultant wave with an amplitude of 0. This is called destructive interference. Standing waves are formed when the two waves of the same frequency travel in opposite directions and interfere with each other. This interference creates a wave that appears to be standing still, hence the name. To create a standing wave in a guitar string, the string is fixed at both ends. So when a wave of vibrations travels down the string and gets reflected back, it interferes with the original wave to create a standing wave. The fixed ends of the string act as nodes, meaning that only certain frequencies of standing waves can be created. These frequencies are called the natural frequencies of the string. When a guitar string is plucked, it vibrates with all of its natural frequencies. But the loudest note is the one with the largest amplitude, or the string's fundamental frequency. The other less intense notes are called overtones or harmonics. The combination of these frequencies creates the unique sound we associate with a guitar. So there you have it. The science of sound waves. Next time you hear a song, you'll know that you're rehearing the vibrations of atoms and molecules that have traveled through the air like waves, creating standing waves that our ears can detect.